Thanks for joining me in this Robotmaster demo. Today I'm going to go over the welding and touch sensing module and how it can be beneficial for you or your company. So here I've got Robotmaster, I've got my part loaded in. Over on my device side, as an example, I'm just going to use this MA2010 by Yaskawa, but this works with Fanuc, Kuka, ABB, UR, all different kinds of robots. And to import this part, I just clicked on this plus icon and it will open up your file explorer and you can go and select your part. Now that I have my part loaded in, I can go ahead and add an operation. And now we'll select welding. And when you click on the welding module, you can see that you're going to get these icons across the top here. These first four are common across the contouring module, the surface path module, and some of the others. So really the items that I want to focus on in this video are going to be specific to welding. So I'm going to click on this welding icon here, and it's going to bring up this menu with some of these different options that are specific to the welding module. The latest way that Robotmaster has decided to find joints that I really like is they have this rolling ball method. And so you can see when I hover over a weld seam, up in the top left corner of the viewport, you can see that there's a green ball, and it is finding where the walls of that joint touch it and creating a bisecting angle. And the reason I like this is because you can expand or shrink the ball radius to fit your gap. So even if you have a CAD file where the weld joint has a gap, you can expand that ball radius and it will still find the bisecting angle for that joint. From there, I'm going to go down and I'm going to start showing some of the weld module specific options here, and I'll start with auto join. To turn these options on for the path, you just click this toggle switch and then you can expand using these arrows. So for the auto join, if I wanted to say weld around a corner, like right here, you can see when I first click that path, I have one weld path up here, but then when I add this second path, it adjusts this vector so that I can go ahead and weld through that in one continuous motion. After that, we have corner stop, and what corner stop does is it's going to automatically detect the wall here and the clamp here, and then it's going to stop the tool path within a certain distance in millimeters. So if I reorient before I turn this on, you can see that we're going right up to the wall and right up to the clamp. If I put in here a 20 millimeter corner stop distance and I turn this on, now you can see it's detecting the wall and the clamp, and it's shortening the path to avoid those obstacles. Extend shorten, this is a more advanced version of the corner stop because it allows you to extend or shorten the path at the start or at the end of the path. So for instance, if I wanted to extend the start for some reason, let's say I do 25 millimeters here, and I wanted to make the end of my path shorter, I could do -10. Then you can see at the beginning of my path, it's extending at 25 millimeters, and where the clamp is, it is reducing the path by 10 millimeters. Push-pull. This allows me to select a push or a pull orientation as well as a degree for what I want that to be. So you can see here, if I do a 45-degree push and I hit apply, it's going to put that orientation on all of the points in that weld path. The next one we have is start and end conditions, and this is one of my favorites, and it tends to be one of our customers' favorites as well. And what this does is it will detect the wall and the clamp, and it will allow the torch to go in at an angle so that we can avoid collisions with the nozzle. So we have the transition angle, which is going to be the angle at which the torch goes into the weld seam. And then we have the transition distance, which is how long it takes to get back to the ideal weld position. So if I click apply here, you can see we're coming in at a 35-degree angle, and it's taking us 100 millimeters to get back to this normal position here. And I can adjust this if I want to get back quicker. I could say 50 millimeters. And then when I program this path, you can see it's going to pop back up pretty quick. And 50 millimeters away from that clamp, it's going to start that sweep as well. Next we have tacking or intermittent welding. And the way this one's broken up is you've got two different tacking modes here. You've got distance and you have fixed number. So I'll go through distance first and then I'll go through the fixed number. So I'm going to turn this on to activate it. I'll set my weld tack length to 10 millimeters and the distance in between my tacks to 50 millimeters. Now the way it's set up right now is it's going to go 10 millimeter tack. From the end of that 10 millimeter tack, there's going to be 50 millimeters before the start of the new tack weld. If I wanted to use a center to center reference, I could check this box right here. And now it would give me a center to center tack weld reference. And as you can see, I can come in here, I can click, and it's going to program all of those points for me. Now one thing I like to show off with this as well is the approach retract. So if we look at this weld path, we probably don't need to come up this high in between each pass. So there's a menu here where I can go in and I can specify how many approach and retract moves I want. So let's say I do my clearance move, I'll make that linear. And then I just want to go straight from my clearance into my welds. So I have an option here to use it only at the start and at the end of the path. So it would be here and here. So I'm going to check that. And then for the weld paths in between, it's going to pull back to this feed height, which I'll set to 10 millimeters. And then when I hit apply, you can see that we have a nice clearance move, and then we're just pulling back whatever we set our feed height to until we get to the end of the path, and then we'll do the full 60 millimeter retract. So that was distance. I'm going to go ahead and go over fixed number. Fixed number allows us again to put in a weld tack length and then how many we want. So if we want 6 welds, I can just put in 6, and you can see it's going to give me 6 10 millimeter tack welds there. And down below I can align these at the start if I want to, or I can align them at the end. And then I can also make sure that I have a tack at the start and at the end, and it will space them accordingly. After that, we have multipass. And the way multipass works is it will program a root pass and then 2 passes on top of that, 3 passes on top of that, and so on as you add layers. You have a couple different options here. This Z up order, what this is indicating is after the root pass, do we want our second pass to be on the wall of the part or on the floor of the part? And then we have the option to keep the same direction. And what this would do is it would create the weld, and then it would retract, come back to the start, and do the second weld, retract, come back to the start, do the third weld. If we uncheck this, then it would do a zigzag motion where it would weld one way, and then weld back the other way, and then weld back the other way, so on and so forth. The number of layers here is going to determine how many welds this puts down. So for 3 layers, it's going to put down 6 welds. And we can see if we zoom in here, it's going to be a root pass, and then it's going to be the second layer, which is 2 welds, and the third layer, which is 3 welds. And the path offset in millimeters here is going to be how far away from each weld it needs to be. So this would be 0, this would be 3 in X, this would be 3 in Y, and that just plays out over the course of the whole multi-pass weld path. So those are the specific parameters that we can use to program. We also have the auxiliary menu, and this is where we can set our arc start and arc end files, as well as our weaving files. So if we have a weaving file number that we want to call, we can also call that from Robotmaster, and then seam tracking parameters as well. So this will all be natively output from Robotmaster to your robot if you're using these functions currently. The next thing I want to go over really quick is the touch sensing. So there's two ways you can do touch sensing. You can do it embedded with the weld program. So if I come in here and I do welding with touch sensing, it's going to ask me what method I want to use, wire or nozzle, and then the order that I want to do the touches in and how many touches I want to do. So for instance, if I'm to keep it with this same path, I'll go in here, I will turn on my start and end conditions, and then you can see when I program this path, it's going to automatically program in those touches as well. So it'll come in, it'll touch, 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 and then it'll do the weld. And it'll output these search functions and these offsets for the program as well. So that's one way to keep it specific to the weld. Another way that I could do it if I wanted a more global touch sense is I could come in here and I could create a touch sense job. So for instance, I could come in here, and touch here, and you can see it's automatically programming in those touches with this distance of 20 millimeters, and it's reorienting those touches. So now that I have this created, I have a touch sensing 1 job, and when I come in here to open a weld job, I can go to the touch sense option, and I can reference that touch sensing 1 job that we just created. And this would allow you to create kind of one touch sense routine and then take that touch sense job and apply those offsets to multiple different welds. So I'm just going to go ahead and delete this, and I want to program this up really quick just to kind of show you what a workflow for programming this part would look like. And I'll go ahead, I'll program this weld, and this weld around here. So I'm going to go to welding, and for this first one, what I want to do is I want to just use the start and end conditions here. Go ahead and click that and hit OK. Got that weld. I'll do this one really quick with my start and end conditions. And there's also presets that we can set here. So I could come in here and add start and end conditions as a preset. I have a last used settings, so if I hit override, you can see it's going to use my last used settings here as well. And so you can set up presets for operations that, you know, a lot of these different welds use the same parameters. So I'll come in and I'll do this weld here, and I'm creating these in separate weld paths so that I can more effectively control the transitions. So again, if I go here, last used, override, now you can see my start and end conditions are automatically checked, and I'll program this weld here as well. And I'll hit apply, and now we have our 3 weld paths, and we can go over into the device side where we can start setting up how we want the robot to move, adding any transitions that we need to, and correcting any kinematic errors that we need to. So I'll go over here, I'll hit calculate, and you can see we are pre-processing all of these operations. So we know green means there's no kinematic errors and no collisions. We do have a collision, it looks like here. I can just click on it and it'll show me that collision. Let me hide these tool paths so that it's a little less messy. And then I also have a collision here, so that's my clamp. So I'm going to I'll work through my collisions first, and we'll kind of go from there. And it's very easy to fix a collision here. So what I can do is I can right click on weld 1. I can go to add a transition after. I can go to manual transition. Let me delete these. And then what I can do is I can scroll through, and what I like to do is get this to a point where it's kind of right in the middle of the collision that I'm trying to avoid. Something like this. And I can click on my torch, and then I can adjust my torch and pull it away from my workspace so that I can avoid that collision like so. I can add that point, and then I can inject that point into my current transition list here. So I'll click OK. You can see we now have gotten rid of that collision by inserting that point. And it looks like we have it's an out of reach here, and we can see that marked by a red dot. And what I want to do, and I could set up a recipe for this, or I could save it as default. I want to prohibit the torch from spinning around the z-axis. So I would really like that torch to be oriented like this. And the way I can do that is I can just lock the Z rotation around my torch. So if I go ahead and do that, click calculate, you can see now we have a green dot saying that there's no kinematic errors, and I can go ahead and click OK. And now we can see that we have a collision in between the two, but our torch is oriented the way that we want. So I'll just really quickly add a transition point in between these two operations. Manual transition, I'll go ahead and slide it somewhere around here. I can click on my torch and then just move it out of the way. Record that point and insert it into my transition. So now our transition looks good. And now what we want to do is we want to weld around these clamps. And so, having experience in robots, I know that I can click on my torch and it's going to give me this TCP, this tool frame. I've got blue as my Z-axis, Y is my green, and X is my red. And I know if I can just rotate around that Y-axis that I can avoid these clamps. And Robotmaster's come up with a very clever way to do this, and they call this optimization. And so when I go into the settings for this weld path, I can go ahead and click optimization. It's going to default to spinning the torch around that Z-axis, but what I want to do is I want to add a map, and I want it to be that TCPY that we were looking at. So I'll select that, I'll give it a range of 20 degrees, I'll click OK, and then I'll have that added up here as an option. And you can add up to 3 maps here, including external axes, so linear rails, rotaries, whatever you want. And you can use these 3 maps to dynamically try to find a solution for your robot that avoids collisions and any kinematic errors. And as you update one of these maps, then it's going to update the other maps as well, giving you a pathway to get that error-free programming. So when I generate this map, over on the left you can see everything that we're checking for. We're checking for singularities, out of reaches, joint limits, over travels, wrist flips, and collisions. And you can see here's that first clamp, and here's the second clamp. And if I move this line around those obstacles, it's going to adjust those paths in that tool frame Y to avoid these clamps. So I can just move this out of the way. I can click OK. And then when I calculate, you'll see that we're not going to have any errors or any collisions on that tool path, because what we've done is we've added a rotation to that tool to that tool as it goes down the path. So as I simulate through, we'll see that robot dip down out of the way, come back to a normal position, and then as we get to clamp 2, same thing, we'll dip out of the way and come back to our weld position. And so this really allows you to quickly get through programming parts, saving you time, And obviously, you don't, if you have another part queued up while your robot's welding, you don't have to take it down. If you have the CAD model, you can go ahead, program it in Robotmaster, and then when it's time to run this part, switch over your tools, download this to the robot controller, and go. So I hope this demo gave you some insight into the welding and touch sensing module, and I appreciate your time. Thank you.